Welcome to the Operation and Maintenance of Permanent Post-Construction Best Management Practices training course for property managers. As a property owner representative, you are responsible for the operation and maintenance or O&M of permanent stormwater quality best management practices or BMPs installed at your property. In this training, you will be provided the necessary information to enhance your knowledge of post-construction BMPs and how to properly operate and maintain these BMPs to ensure water quality. Click Start to launch the course. By the end of this course, you will be able to describe the concept of permanent stormwater post-construction BMPs, identify the types of BMPs installed on your property and their impact on stormwater quality, recognize your roles and responsibilities regarding the O&M of BMPs, outline the importance of performing routine inspections and maintenance, identify the O&M plan and the type of information it provides, identify the O&M log and the type of information it contains, identify the signs that your BMP needs maintenance, and identify the maintenance activities to ensure long-term performance of all BMPs. This course consists of 3 parts. Part 1 consists of Module 1, Overview. Module 2, Introduction to Permanent Post-Construction BMPs, and Module 3, My Roles and Responsibilities. Part 2 consists of Module 4, Operation and Maintenance of Post-Construction BMPs. Module 5, Source Control BMPs. And Part 3 consists of Module 6, Assessment. You are already through with Module 1. Click the highlighted module to proceed to Module 2. How familiar are you with post-construction BMPs? Before we begin this module, let's test your existing knowledge on post-construction BMPs. Take a look at the images displayed on the screen and select the set of images that contains all post-construction BMPs. Select the correct option and then click Submit. What then are permanent post-construction BMPs? Post-construction BMPs are permanent stormwater practices and site design features that remain after construction is complete. These BMPs can store, treat, infiltrate and/or reduce the volume of runoff from developed sites, and help reduce the discharge of pollutants in post-construction runoff, which improves water quality. Some examples include enhanced swales, permeable pavements, and grass pavers. These BMPs are collectively known as Low Impact Development or LID BMPs. LID BMPs are means to control stormwater quality at its source, using methods to maintain or restore the natural hydrological character of a site by reducing runoff, improving water quality, and providing groundwater recharge. In addition, post-construction BMPs can help reduce the discharge of pollutants and stormwater runoff by preventing erosion, controlling sediments and other pollutants from developed areas, and promoting stormwater infiltration. This is important because post-construction runoff can have a direct impact on the quality of our island waters. Therefore, post-construction BMPs can help protect our streams and oceans. Post-construction BMPs have 3 categories. Low-impact design or LID site design strategies is the first, source control BMPs is the second, and treatment control BMPs is the third. The 3 work together to ensure protection of stormwater, and ultimately, of our streams and oceans. LID site design strategies and source control BMPs can be incorporated in the site planning and design process to reduce the amount of stormwater runoff that may require treatment by treatment control BMPs. Click each category to learn more. During the project's design phase, project designers incorporate LID strategies in their site design. These strategies offer low impact to the natural environment during development to help reduce the amount of post-construction runoff, and the amount of runoff that must be treated. Examples of LID site design include conserving natural areas, soils, and vegetation, minimizing impervious surfaces to promote infiltration, minimizing soil compaction to promote infiltration and plant growth, and directing parking lot runoff to landscaped areas.
When designing, preserve natural areas such as areas along streams and slopes. Minimize soil compaction by designating truck traffic in areas where there will be future roadways instead of future landscaping. Conventional design directs runoff directly to the road from impervious areas. Low-impact development design reduces directly connected impervious areas by directing runoff to landscaped areas first. Minimize impervious surfaces by using less traditional pavement, creating more landscaped areas, and/or by using pervious areas for rainwater to soak into the ground instead of going to the ocean.
Source control BMPs are low-technology practices that prevent pollutants from coming in contact with runoff, preventing polluted runoff from discharging into the storm drainage system.
Common source control best management practices include keeping dumpsters' lids closed, covering loading docks, labeling storm drains to indicate where the water flows, repairing, fueling, and washing equipment and vehicles under cover, paving repair areas with smooth impervious surface, using drip or timed irrigation, grouping plants by water requirements, and directing water runoff from parking lots to landscaped areas.
The last category of BMPs is treatment controls. These can treat stormwater runoff from impervious surfaces through retention, biofiltration, or alternative means. Click each treatment mechanism to learn more. A retention BMP is a type of treatment control BMP. Retention BMPs treat stormwater by retaining runoff on-site with reduced or minimal off-site discharge. Runoff remains on-site by infiltration into the soil, evaporation, or evapotranspiration from plants. Click each retention BMP image to learn more. Infiltration basin is a shallow impoundment that is usually vegetated. It infiltrates runoff into the underlying soil and eventually into the water table. Infiltration trench is a rock-filled trench with no outlet where stormwater runoff is stored in the void spaces between rocks and infiltrates through the bottom into the soil. Rain garden or bioretention basin is a shallow depression designed to hold and filter stormwater runoff using plants and soils. Permeable pavement is a porous surface that temporarily stores rainwater in an aggregate layer until it infiltrates into the underlying soil. Dry well is a prefabricated and perforated underground storage unit with a drain gate and no outlet that allows stormwater to infiltrate into the soil. A biofiltration BMP is another type of treatment control BMP. BMPs use biofiltration to remove pollutants from runoff by filtering stormwater through vegetation and soil. Click each biofiltration BMP image to learn more. Vegetated swale is a broad shallow earthen channel that is vegetated with erosion-resistant and flood-tolerant grasses. Runoff enters the swale at one end and exits at the other end. Vegetated buffer strip is a grass slope vegetated with turf grass that is designed to accommodate sheet flow. Green roof is a roof of a building that is partially or completely covered with vegetation and a growing medium planted over a waterproofing membrane. Alternative compliance BMPs may be used if retention and biofiltration are not feasible. They are commonly known as manufactured treatment devices. These BMPs filter stormwater runoff through several mechanisms such as detention, settling, filtration, and vortex separation. Examples include filtration devices, like drain inlet filters, baffle boxes, and hydrodynamic separators or vortex separators.
Examples of retention BMPs are retention basins, infiltration trenches, rain gardens, and permeable pavements. Rainwater harvesting and reuse is also a form of retention. Examples of biofiltration BMPs are vegetated swales, vegetated biofilters, and green roofs.
Why is ongoing inspection and maintenance of post-construction BMPs important? Post-construction BMPs need ongoing and proper maintenance to ensure their long-term performance, much like the mechanical systems that need routine maintenance to perform. Routine maintenance helps avoid costly rehabilitative repairs resulting from inadequately maintained BMPs. The water quality rules require that the post-construction BMPs be inspected at least quarterly and maintained at least once per year. Finally, it is required to maintain the post-construction BMPs in compliance with your approved O&M plan. Your O&M plan contains specific guidance on how to manage your post-construction BMPs. The O&M plan is prepared by the project owner and submitted to the Stormwater Quality Branch of the Department of Facility Maintenance for review and approval. The O&M plan must be prepared by using the city's template. It includes a summary of all permanent stormwater BMPs installed at the property and their location. It provides the frequency of the inspections and specific maintenance activities for each type of BMP installed on site. It also specifies the maintenance crew needed for BMP maintenance. For example, it clarifies whether maintenance can be done in-house or if contractors are needed. It specifies the type of equipment needed for BMP maintenance and whether specialized equipment is needed. Finally, the O&M plan contains an O&M log which is used to record the BMP condition during inspections. This log is termed as the O&M inspection form in the city's template. In this module, you will learn about your roles and responsibilities with regard to the operation and maintenance of the post-construction BMPs installed at your site. As per the water quality rules, a property owner can designate one or more representatives to be responsible for ensuring proper operation and maintenance of all installed BMPs. The property owner's representative can be a property manager, resident manager, or a homeowners association. As the property owner's representative, you play a key role in complying with the water quality rules. Your roles and responsibilities include implementing the approved O&M plan, performing routine inspections of post-construction BMPs, performing routine maintenance of post-construction BMPs, allowing the city access to the BMPs for annual inspections to confirm compliance with the approved O&M plan. Click each tab to learn more. You should ensure that the maintenance personnel are familiar with the approved O&M plan and its location, know where all post-construction BMPs are located on site, and understand the function of all installed BMPs. You should also ensure that inspections of all post-construction BMPs are performed at least quarterly, that is 4 times per year, recorded in the O&M log, also known as the O&M inspection form, and kept on-site or electronically accessible from the site at all times. You should perform routine maintenance of post-construction BMPs. This includes performing maintenance at least once per year, recognizing conditions when maintenance is needed and conditions after maintenance is performed for all installed BMPs, coordinating maintenance activities based on the BMP condition and required frequency, designating a work crew to perform the necessary maintenance duties, if this resource is available to you, designating maintenance contractors for work requiring specialized maintenance that you are unable to conduct, and coordinating proper disposal of accumulated waste and/or sediment resulting from routine maintenance. You should allow city inspectors access to the BMPs for annual inspections to confirm compliance with the O&M plan. When city inspectors arrive at your site, you should provide them with all O&M documentation immediately upon request. This may include your O&M plan, O&M log of inspections, and other related documentation, and following their inspection, you will receive an inspection report. You should review it and follow the directives and evaluate the recommendations within to achieve compliance. In this module, you will learn about the operation and maintenance or O&M of post-construction BMPs. In order to know if your BMP is working properly, you need to understand how it manages stormwater runoff and how it functions. For example, rain gardens are designed to temporarily store stormwater, which may look like ponding. However, water should be able to soak into the ground within 24 hours in order to accept more water from the next storm. On the other hand, vegetated swales are designed to be flow-through systems, without standing water. Some of the individual components that make up the different LID BMPs are common to a lot of them. For example, a rain garden and an infiltration basin both have inlet structures. These common structures generally have the same maintenance requirements. Most LID BMPs require sediment and trash removal, vegetation trimming, and drainage check. Some LID BMPs may require specialized maintenance using commercial-grade equipment. Such is the case of permeable pavements, manufactured treatment devices, and other LID BMPs with inlets or other underground components. These are examples of LID BMPs requiring periodic sediment and trash removal, vegetation trimming, and drainage check. Routine inspection and maintenance is critical to the long-term success of the installed BMPs. It will prevent standing water within the BMPs and ensures that the flow is unobstructed. LID BMPs must be inspected a minimum of 4 times per year, quarterly, and must be maintained at least once a year. Certain LID BMP systems may require more or less frequent inspection and maintenance depending on the amount of runoff they receive, the quality of runoff they receive, and the upstream land use. O&M records can be used to request a reduced inspection and maintenance schedule after a minimum of 1 year of ongoing O&M and with a written approval from the Stormwater Quality Branch of the Department of Facility Maintenance. A request to amend is required with supporting documentation of the adjusted inspection and maintenance. Let's take a closer look at the recommended maintenance for LID BMPs. Here is a recommended inspection schedule displaying maintenance activities for BMPs that require sediment and trash removal, vegetation trimming, and drainage check. Note that LID BMPs are site-specific. The routine maintenance activities are provided as general guidelines only. For specific O&M recommendations regarding the BMP installed at your property, check the O&M fact sheet provided in the resources and its manufacturer's recommendations. Check for persistent ponding or standing water after 24 hours following a rainfall. Do this after a major rainfall in the first few months following construction, then at the beginning and end of the wet season. Remove sediment or trash clogging the filter surface or underdrain and check for overcompaction. Check for visible trash, leaves, and other debris. Do this at the beginning and end of the wet season and after a major rainfall. Rake in and around the system to clear inlets and outlets of leaves and other debris obstructing flow. Check for visible sediment accumulation in the filter bed or in the inlets and outlets. Do this at the beginning and end of the wet season, and after a major rainfall. Rake the hard surface to remove excess sediment, typically considered to be more than 2 inches of accumulated material. Also remove any accumulated sediment from inlets and outlets. Check for erosion around inlets and areas with bare soil. Do this at the beginning and end of the wet season and after a major rainfall. Remove obstructions and sediment to allow water to flow freely and disperse over a wide area. Add or replace vegetation in eroded areas. Check vegetation for signs of distress or disease. Do this at the beginning and end of the wet season, November to March, or as needed to achieve healthy vegetation. Water plants until established. Cut and remove any dead or dying vegetation and decaying plant material. Check that intended vegetation covers at least 90% of the area. Do this at least quarterly, monthly if possible. Remove weeds and replace with intended plants to achieve at least 90% coverage. Maintain plants according to specified guidelines like trimming, mowing, etc. Check the inlets and outlets for evidence of deterioration. Do this annually. Repair or replace damaged structural parts such as inlets, outlets, and sidewalls. What is wrong with these pictures? These graphics show a bioretention area before and after vegetation trimming, a common maintenance mistake related to vegetation trimming. Maintenance staff who are unfamiliar with this type of LED BMP and its function may wonder, what are those weeds doing in that planter? Well, some native bioretention plants may look like weeds to an untrained eye, but they are in fact not. Untrained maintenance staff may be tempted to overtrim or remove the native plants that were installed in the system to treat stormwater runoff. To avoid this mistake, do the following. Inform all maintenance personnel about the types of vegetation allowed in your BMP. Point out which plants are invasive and should be removed before they become established, and educate landscape crews on how to maintain the BMP properly for effective long-term performance. Permeable pavements are designed to detain stormwater in the void spaces and allow it to infiltrate into the underlying soil. Some examples are shown on the screen. Because the permeable surface acts as a filter, it must be cleaned periodically. In general, maintenance of permeable pavements consists of monitoring the surface for sediment buildup, and removing the buildup as needed, to maintain the pavement's permeability. Take a look at the recommended inspection schedule and maintenance activities for permeable pavements. The routine maintenance activities are provided as general guidelines only. For specific O&M guidance, check the manufacturer's recommendations. Check to ensure the permeable pavement drains within 24 hours after rainfall. Do this quarterly. Sweep or vacuum the surface. If necessary, pressure wash it while wet vacuuming any runoff, and clear the underdrains. Check for visible trash and debris on the permeable pavement and upstream contributing surfaces. Do this quarterly. Use leaf blower to remove superficial leaf debris. Vacuum clean the surfaces using a commercial-grade vacuum sweeper. Check for visible sediment on the permeable pavement and upstream contributing surfaces. Do this quarterly to avoid clogging. Clean surfaces with a vacuum sweeper. Check for moss growth in the voids. Do this quarterly. Pressure wash surface while vacuuming any runoff. Also, remove weeds growing on the pavement. Check for loose pavement and misaligned or settled paver blocks. Do this quarterly. Vacuum loose pavement, patch for stabilization, and replenish aggregate in joints or grids as needed. Check for bare soil in areas that drain to the permeable pavement. Do this quarterly. Stabilize bare areas with landscaping or mulch to prevent soil from being washed onto the pavement. Check for sediment buildup and ponding at the under drain and outlet. Do this quarterly. Jet, vacuum, or rod under drain and outlet and remove sediment. Let's discuss O&M mistakes related to permeable pavements. Maintenance staff who are unfamiliar with permeable pavements may wonder, is this surface really porous? From the surface, porous asphalt and pervious concrete appear to be the same as conventional pavement, except that it has small air voids present between the aggregate pad and encourage infiltration. Permeable pavement function is significantly reduced when the matrix becomes clogged with fine sediments. To preserve its infiltration capacity, you need to do the following. Inform all maintenance personnel about the purpose of the permeable pavement and how to maintain it properly. Do not store sand, soil, mulch or other landscaping materials over the surface to avoid clogging it. Do not seal the pavement surface. Should pavement raveling occur, loose aggregate can be removed using a vacuum sweeper, but never seal the surface with a slurry or other sealer. In this lesson, you will learn about manufactured treatment devices. Manufactured treatment devices are proprietary devices designed differently to treat stormwater and may have unique maintenance needs. Some examples of manufactured treatment devices include filtration devices, baffle boxes, and hydrodynamic or vortex separators. Be sure to follow the manufacturer's recommendations for specific inspection and maintenance requirements. You will now take a look at the recommended inspection and maintenance activities for manufactured treatment devices. Check that water drains into the treatment device between storms as specified by the manufacturer. For specific guidance, see the manufacturer's recommendations. Typical maintenance could include removing blockage to promote drainage, replacing proprietary products or components, or flushing or repairing overflow pipe in a way that it does not lead to an illegal discharge. Check for visible sediment, trash, and debris in the media material, vault, or piping. For specific guidance, see the manufacturer's recommendations. Remove blockages using a Vector truck, if applicable, and dispose of waste and sediment properly. Check for mosquito larvae in the treatment unit. Do this as needed. Clean out the device to prevent a potential vector problem. You have just joined as a property manager for an apartment condominium. You find that the condominium has a permeable pavement and an infiltration trench installed at the site. Based on the knowledge you have gained so far, answer the questions that follow. Let's go. You've reached the last part of this module. In this lesson, you will take a closer look at the source control BMPs. Source control BMPs are ways to physically separate potential pollutants, such as sediment, oil, and grease, trash, pesticides, metals, and pathogens from the storm drain system. So, how can you control exposure of stormwater to pollutants at your site? First, prevent stormwater from contacting work areas. This means setting up fueling areas, storage areas, and other work areas in such a way that stormwater runoff does not pass through them before reaching the storm drains. For example, you can build curbs or berms around work areas to divert drainage away from them. Second, use measures to prevent pollutants from contacting surfaces that come into contact with stormwater runoff. Some examples include storing chemicals or oil containers in a secondary containment to prevent and control spills, and using covered trash storage areas. Here are some general areas and sources of stormwater pollution that every property manager needs to address at their site to prevent stormwater pollution and discharge of contaminated runoff to the storm drain system. Click the numbers shown on the screen to gain insight into each of them. Consider these BMPs for your outdoor trash storage areas. Locate trash storage areas away from storm drains. Cover area with roof, awning or attached lids. Use line dumpsters, or drip pans underneath dumpsters, or perimeter berm around dumpster area. Inspect for leaks and drips. If found, spot clean as needed. Post no littering signs. Prohibit dumping of hazardous materials or any liquid. Never wash down or rinse with a hose. Contact the leasing company for cleaning. Consider these BMPs for loading docks. Preclude run-on and runoff from loading docks. Protect nearby storm drain inlets. Load and unload only at designated loading areas. Conduct loading and unloading in dry weather, if possible. Load and unload all materials and equipment in covered areas, if possible. Check loading and unloading equipment regularly for leaks. Consider these BMPs for storm drain inlets. Provide stenciling or labeling of all storm drain inlets and catch basins within facility boundaries to indicate whether the flow is to the storm drain, sewer, or an oil-water separator. Inspect signage regularly and maintain as appropriate to ensure legibility. Inspect storm drains at least annually for structural deterioration or significant buildup of debris or sediment. Protect storm drains prior to construction work on property. Do not allow any solids, liquids, or slurries to enter storm drains. Consider these BMPs for paved parking areas. Direct stormwater runoff from paved parking areas to landscaped areas or other post-construction treatment control BMPs. Clean leaves, trash, sand, and other debris regularly. Provide an adequate number of covered trash receptacles to prevent littering. Reseal or pave only on dry days and stop immediately before rainfall. Use dry absorbents on spills and drips and dispose properly. Do not power wash unless absolutely necessary. If you must pressure wash, discharge wash water to the sanitary sewer or a landscaped area. Do not allow wash water to enter storm drains. Consider these BMPs for vehicle and equipment repair. Preclude run-on and runoff from vehicle repair areas. Direct runoff to a dead-end sump for collection and disposal. Keep drip pans or containers under vehicles or equipment that may drip during repairs. Contain liquid wastes and use spill pallets for liquid containers. Immediately clean up spills. Do not pour waste fluids or oil down floor drains, sinks, storm drain inlets, or the sanitary sewer. Avoid hosing down work areas. If work areas are washed, collect and direct wash water to an on-site oil water separator that is connected to a sanitary sewer or a blind sump. Consider these BMPs for vehicle and equipment cleaning. Use cover, perimeter berm, and clearly mark designated wash area. Recycle or treat wash water prior to discharge to the sanitary sewer system. Direct wash water to the sanitary sewer with an approved sewer connection permit, or to an engineered infiltration system, or to an equally effective alternative. Do not conduct oil changes and other engine maintenance in the designated washing area. Perform these activities in a place designated for oil change and maintenance activities. Do not allow wash water to enter the storm drains. Consider these BMPs for fueling areas. Provide cover over fueling areas. If large equipment or vehicles prohibit the use of covers, preclude run-on and runoff. Use dry cleanup methods such as sweeping, or use rags and absorbents for leaks and spills. Install vapor recovery nozzles to help control drips. Use secondary containment when transferring fuel from the tank truck to the fuel tank. Protect storm drains in the vicinity during transfer. Post signs at the fuel dispenser warning vehicle owners or operators against topping off fuel tanks. Consider these BMPs for automatic irrigation systems. Use drip or timed irrigation to minimize excess runoff. Repair leaks in the irrigation system as soon as they are observed. Check irrigation schedules so fertilizers or pesticides will not be washed away. Consider these BMPs for landscaped areas. Landscaped areas should be used to absorb runoff wherever possible. Limit runoff from landscaped areas to impervious areas. Protect slopes and channels. Use mulch or other erosion control measures on exposed soils. Do not use pesticides and fertilizers during wet weather or when rain is forecasted, and minimize their use during dry weather. Do not blow or rake leaves, grass, or garden clippings into the street, storm drains, or waterways. Dispose of grass clippings, leaves, sticks, or other collected vegetation as garbage, or by composting. Consider these BMPs for outdoor material storage. Cover materials to protect them from rainfall, run-on, runoff, and wind dispersal. If infeasible, install sediment control devices around site perimeter and at storm drains. Enclose materials or provide secondary containment like berms, dikes, or curbs. Inspect storage areas regularly for leaks or spills. Keep containers in good condition, without corrosion or leaky seams. Consider these BMPs for outdoor work areas. Conduct undercover to prevent rain from falling on the work areas. Locate work areas away from storm drains. Preclude run-on by using berms or perimeter controls. Protect materials from rainfall, run-on, runoff, and wind dispersal. Inspect storage areas regularly for leaks or spills. Keep storage areas clean and dry. Consider these BMPs for outdoor process areas. Outdoor process equipment operations may include rock grinding or crushing, painting or coating, grinding or sanding, degreasing or parts cleaning, landfills, waste piles, wastewater and solid waste treatment and disposal. Conduct undercover to prevent rain from falling on the process areas. Inspect storage areas regularly for leaks or spills. Dry clean the work area regularly to keep it clean. You have reached the end of this course. In this course, you have learned about permanent post-construction BMPs and related concepts, types of post-construction BMPs and their impact on stormwater quality, roles and responsibilities as the property owner's representative, importance of your O&M plan and the O&M log to document inspection, importance of routine inspection and maintenance of post-construction BMPs, and key performance indicators to be aware of during inspection and maintenance activities. This concludes the operation and maintenance of permanent post-construction best management practices training course. Hope that you enjoyed it and have learned a lot. We hope that the knowledge you gained from this course is able to transfer to your job. As a bonus, you can download the brochures from the link displayed on the screen. You can keep these brochures handy to help you become familiar with the O&M requirements at your site. For more information, visit the following websites. If you have any questions regarding post-construction stormwater management, contact the Stormwater Quality Branch at 808-768-3244.